This video is on exercise 9C of Pure 2 textbook A-level maths. So we are going to start with question 10. The curve C has equation x is equal to 4 cos 2y. A. Show that the point Q lies on C. Okay. So whenever the question is about showing a point that is on a specific graph, basically, what we need to do is simply plug in the points, and we should expect both sides to agree with each other, or just we get the same number on both sides of the equality sign. That means that point is on that graph. So here we just need to substitute 2 pi by 6 into this equation. So we have 2 is equal to 4 cos 2 times pi by 6. And okay, so 2 times pi by 6 is pi by 3, which is 60 degrees, and cos pi by 3 or cos 60 is a half, which means we will have 4 times a half, which is equal to 2. So that this point lies on C. That's part A. Part B. Show that dy by dx is equal to minus 1 over 4 root 3 at Q. So for part B, first of all, we just need to differentiate this function. So this equation in this case. So again, this is implicit differentiation. So x differentiates to 1. So part B, x differentiate. This is the gradient for cos 2y. So x differentiates to 1. And on the right hand side, we should be careful because so we can write down 4 because that's a constant. So 2y 2y differentiates to 2 dy by dx, but we keep that for now. So we have a dy by dx term, but we just don't write that now. And cos differentiates to minus sine, because because this is cos 2y, we will have minus sine 2y. And now it's better to include the dy by dx term. Okay, so we can now simplify this. So we are going to have minus 8 sine 2y dy by dx. So we haven't done yet because we need to show that the derivative at this point is equal to this number. So now let's rearrange this. Dy by dx is equal to divide both sides by minus 8 sine 2y. We will get minus 1 over 8 sine 2y. Now is the time to substitute the coordinates of Q into this derivative. So here we only have the y term, which means we need to use pi over 6 here. So at Q, we spelling error, we have, okay, so dy by dx is equal to minus 1 over 8 sine 2 times pi by 6, or just, pi by 3 in simpler terms. Now dy by dx is equal to minus 1 over 8 times, okay, so sine pi by 3 is root 3 over 2, which is equal to minus 1 over 4 root 3. And this is exactly what we wanted to show here. Right, now let's do part C. Find an equation of the normal to C at Q. Give your answer in the form ax plus by plus c is equal to 0, a standard form of the straight line, where a, b, and c are exact constants. Right. So now we know the gradient at Q, but we should be careful since we want to work out the normal, the equation of the normal. Then the gradient of the normal is the negative reciprocal of the gradient of the tangent. from chapter 5 of pure 1, which means the gradient, or just show this by m as usual, the gradient of normal is equal to, so the gradient is the gradient of the for divided by dx is equal to -1/4 root 3, and the negative reciprocal of this is just 4 root 3. And now we have the point, that's point Q. So now we can use the equation of the straight line to work out the equation of the normal, which is, this is the formula, y minus y1 is equal to m times x minus x1, where y1 and x1 are your coordinates, the coordinates of the point, m is the gradient. So y minus pi by 6 is equal to 4 root 3 times x minus 2. We should be careful, because if we leave our answer in this form, in this specific question, we will lose a mark, because the question is asking us to give the final answer in this form. Now we need to do some rearranging. So we can keep pi minus 6 here, and we will have 4 root 3x minus 8 root 3. So we need to bring each of these terms to the left hand side. We will get y minus 4 root 3x plus 8 root 3 minus pi by 6 is equal to 0. And that's it. So this is now in the standard form, and this is our c term, and then this is our b, and our a value is 1. So that's it for this question, question number 10. So this can be counted as an exam style question, but one of those questions which is considered as the easier ones. Question 11, differentiate the following functions. Right, the first one is, let's say it's y is equal to sine s squared 3x. And now we want to differentiate this. So almost all of these are chain rule and chain rule differentiations. So the first one, we write dy by dx is equal to, so whenever we have sine of something, sine of, let's say, a, we differentiate a, and that comes out as the as a basically multiplier, and then we differentiate this trigonometric function, and we will use the derivative of that. In this case, that's cos a. So it will be the derivative of inside times the derivative of this specific trigonometric function, and that will be the answer. So in this case, we can rewrite this as sine 3x squared. So these two forms are the same exactly. That means we need to first of all find the derivative of this term. So 3x close bracket squared differentiates to 2 times 3 times 3x, and now we differentiate sine, which differentiates to cos, and times 3x squared, 3 cos 3x squared. Sorry, it doesn't have 3. This one was extra, sorry. Okay, so now we can this differentiates to cos 3x, because it the power will be reduced by 1. Now this simplifies to 6 sine 3x cos 3x. This one is not a hard differentiation, but it's very easy to make mistakes, because, for example, I was about to make a mistake at this point. Even though I knew what I was doing, still it's possible to make a mistake. And even here, I when I was differentiating, I said it's 3 sine 3x, but for some reason I forgot to write the sine term. And then, that could have caused an issue. So now we have this function, which is y is equal to e to the power of x plus 1 squared. So whenever we have an exponential function, we first of all differentiate the power, and that comes out as the multiplier of just basically the whole function. In this case, we first need to differentiate x plus 1 squared, which is this term. So this differentiates to, so dy by dx is equal to 2 times x plus 1 times e to the power of x plus 1 squared. This one was very straightforward. C, y is equal to the natural log of cos x squared. We start by writing and dy dx is equal to. So whenever we have the natural log of something, that's usually of this form. So when we have natural log of f of x, this differentiates to f dash x over fx, which means whatever is inside, you find the derivative of that, and that is your numerator, and the denominator is just the function itself. So in this case, the denominator is cos x squared, and now the numerator is the derivative of this function. So cos x squared differentiates to 2 times, so cos x differentiates to minus sine, and the power also decreases by 1 minus sine x, because 2 minus 1 is 1. And simplifying, minus 2 sine x over cos x squared. Again, I forgot to include the cos term, so let's just go back. Cos x. So what happens here is that 2 comes down, and then we will have cos x, and now the derivative of the inside, which is minus sine x. So yeah, this is one way of doing these chain rules. Of course, we can use the the proper formulated way of chain rule, and the good thing about using that type of method is it reduces the risk of making mistakes. But the method that I'm using, which is technically doing everything in your head, there's high chances of making mistakes. And that gives you minus 2 sine x cos x over cos x squared. And this cos x cancels out with this power, and as your final answer you will get minus 2 sine x over cos x, which can be written as minus 2 tan x. D, y is equal to 1 over 3 plus cos 2x. Before we start differentiating this, let's rewrite this in this form: 3 plus cos 2x to the power of minus 1. Right. Dy by dx is equal to, again, the power comes down, minus 1 times the derivative of inside. So cos 2x differentiates to 2 times minus sine 2x, and then this times the bracket with the power minus 1. 3 plus cos 2x minus 2. Now let's simplify this. We have 2 sine 2x over, since this has a negative power, this goes down to the denominator, 3 plus cos 2x squared. And that's it. Finally, E, y is equal to sine 1 over x. Right, another chain rule, and we start by differentiating inside. So 1 over x differentiates to, because 1 over x can be written as x to the minus 1. And this differentiates to minus x to the minus 2. Or simply minus 1 over x squared. Minus 1 over x squared times sine differentiates to cos 1 over x. Now we can simplify this, which is equal to minus cos 1 over x squared. Right, that's it for this video. Make sure to subscribe for future videos, because I'm going to cover all the exercises. And thanks for watching. Good luck.